Hi everyone, I will solve Q2018 question number 44. A spacecraft forms a circular orbit at an altitude of 150 km above the surface of the spherical Earth. Assuming the gravitational parameter mu equal to 3.986 into 10 to the power 14 meter cube per second square and radius of Earth r equal to 6400 km, the velocity required for injection of spacecraft parallel to the local horizon is. So this problem is related to two-body problem in spaceflight mechanics. To know more about it, you can refer to this lecture video in NPTEL. First, we will know what is the two-body problem. In two-body problem, there are two bodies of mass m1 and m2. One mass m1 is taken at origin, and mass m2 is taken at position vector r from the origin. This position vector r makes an angle theta from the eccentricity vector e, and this theta is also called true anomaly. When theta is equal to 0, then the position at which the mass m2 will be is called the periaxis. The line joining this mass m1 and periaxis is called epsilon. The velocity of the mass m2 is given by r dot, and it makes an angle gamma, which is called flight path angle, with perpendicular velocity along the perpendicular of the position vector. So the equation of motion is given by Newton's second law of motion, which is r double dot equal to minus mu upon r cube r vector. R double dot is nothing but acceleration of mass m2, and mu is nothing but g into m1, which is called gravitational constant of mass m1. Here g is universal gravitational constant. And if you solve this equation, you will get r equal to h square upon mu 1 upon 1 plus e cos theta, where h is angular momentum. This equation is solved by assuming the Keplerian motion. So we can also find the perpendicular velocity, E perpendicular equal to mu upon h 1 plus e cos theta, and radial velocity equal to mu upon h e sin theta. So if orbit is circular, then we put E equal to 0 in the orbital equation, r equal to h square upon mu 1 plus e cos theta. So this term will be 0. So we will get r equal to h square upon mu, which is also with h equal to under root mu r. So here we have two velocity, perpendicular and radial velocity. Tangential and radial velocity. If tangential velocity we put equal to 0, we will get it as mu upon h. And here radial velocity put equal to 0, then we will get 0. So our net velocity will be given by tangential velocity equal to mu upon h. If we put h equal to under root mu r, we will get it under root mu by r. So this is the orbital velocity in circular orbit. So in the problem we have to find the orbital velocity in circular orbit of altitude 150 km, and mu is given at 3.986 into 10 to the power 14 meter cube per second square, and r is 6400 km. So what is given at, if this is Earth and the object is orbiting at altitude h, which is 150 km, and this radius of Earth is RE, which is 6400 km. So the position vector r from the center of Earth is RE plus h, which is nothing but 6550 km. In meter it will be 6.55 into 10 to the power 6 meter. So orbital velocity p will be under root mu by r. Value of mu is given in the problem 3.98 into 10 to the power 14. meter cube per second square. 3.986 in 10 power 14. 986 in 10 power 14, and R is 6.55 into 10 to the power 6. So now we have to put this value in the calculator. So if you put this value in the calculator, you get 7800.959 meter per second. So our answer is 7800.32 decimal, it will be 96 meter per second. This is the correct answer. Thank you.